MCV4U1, Chapter 1, Introduction to Calculus, Session 6. In this session, we are going to work on questions on page 19 of the textbook, 19 and 20 of the textbook, exercise 1.2. First question is question number 4. Simplify each of the following difference quotients. Part A and C were assigned last session. F of A plus H minus F of A over H is called difference quotient of the function y equals f of x and x equals a. Part A is difference quotient of f of x equals x3 when x is 5. And part C is difference quotient of f of x equals 1 over x and x equals 1. To simplify the difference quotients in part A, we expand 5 plus h to the power of 3, subtracted by 25 and divided by h. 5 plus h to the power of 3 is 125 plus 75h plus 15h2 plus h3. If you subtract it by 125 and 125 get cancelled, divided by h, which can be reduced as 75 plus 15h plus h2. Part C, we can rewrite it as 1 over h times 1 over 1 plus h minus 1. Notice that a over b and 1 over b times a are the same. A over b and 1 over b times a are the same. We find the common denominator inside the bracket. Common denominator is 1 plus h. The difference quotient can be written as 1 over h times 1 minus 1 minus h, which is minus h divided by 1 plus h. We reduce it and we have minus 1 over 1 plus h. Question number 5. Rationalize the numerator of each expression to obtain an equivalent expression. For each of them, we times the fraction by the conjugate of numerator and divide it by the same thing. We use the difference of squares and simplify it. 16 plus h minus 4 over h, if we multiply it by the conjugate of numerator and divide it by conjugate of numerator, it's going to be 16 plus h minus 16 over h times square root of 16 plus h plus 4. 16 and 16 get cancelled. We reduce it by h, and we find the final answer as 1 over square root of 16 plus h plus 4. Similarly, for part B, we times the numerator and denominator by the square root of h2 plus 5h plus 4 plus 2. If we times this expression by its conjugate, we get h2 plus 5h plus 4 minus 4. 4 and 4 get cancelled. h2 plus 5h can be factored as h times h plus 5. And if we reduce the fraction, we find h plus 5 divided by square root of h2 plus 5h plus 4 plus 2 as equivalent to the given fraction. Part C, we multiply both the numerator and the denominator by conjugate of numerator, which is square root of 5 plus h plus square root of 5. Square root of 5 plus h minus square root of 5 times its conjugate is 5 plus h minus 5, which is h. We reduce h from the numerator and the denominator, we reduce the fraction by h. Then the final answer would be 1 over square root of 5 plus h plus square root of 5. Question 6. Part B is assigned assertion. Determine an expression in simplified form for the slope of the secant PQ. y2 minus y1 divided by x2 minus x1 is the slope of the line. 1 plus h to the power of 3 plus 2 minus 3 divided by 1 plus h minus 1. If we expand 1 plus h to the power of 3 and simplify it, we have 3 plus 3h plus h2. Question number 7. Consider the function f of x equals x3. Copy and complete the following table of values. P and Q are points on the graph of f of x. To complete first column, we plug in 2 into the function and we find the y value of p, which is 8. To complete the second column, we plug in 3, 2.5, 2.1 and so on into f of x equals 3 and we find y values. For 3 we get 3 to the power of 3, 27. For 2.5 we get 2.5 to the power of 3 and we calculate it. Then for last column we use y2 minus y1 divided by x2 minus x1 and we find the slope. If we plug in 2.5 we get 15.625, 2.1 we get 9.261 and so on, and we calculate the slope. Part B is asking use the result in part A to approximate the slope of the tangent line to the graph of f of x at point P. As you see, the slope of the tangent line is getting close to 12. Next part is asking to find the slope of the secant line by considering Q with the x coordinate of 2 plus h. Slope of PQ is going to be 2 plus h to the power of 3 minus 8 divided by 2 plus h minus 2. This can be simplified as 12 plus 6h plus h2. Next part is asking to find the slope of the tangent line using this expression. We know slope of that tangent line is the limit of the slope of secant line as h approaches 0. When h is getting close to 0, 12 plus 6h plus h2 is getting close to 12. Next part is asking to make a comparison between the result in the table and the result in this part. They are the same. The graph of y equals x3 and the tangent line at x equals 2 at point 2 and 8 is shown in this diagram. In question number 9 and 10, we are looking for the slope of the tangent line to the graph of the given function at the given point. 9 part B, slope of the tangent line to the graph of y equals square root of x minus 5 at x equals 9, and 10a, the slope of the tangent line to the graph of y equals 8 over x at x equals 2. Slope of the tangent line would be limit of f of 9 plus h minus f of 9 divided by h as h approaches 0. To calculate this limit, we multiply it and divide it by the conjugate of the numerator. The numerator times its conjugate is h. The denominator times the conjugate of the numerator is h times square root of 4 plus h plus 2. We cross h from the numerator and the denominator, and if h approaches 0, the limit would be 1 over square root of 4 plus 2, which is 1 over 2 plus 2, 1 over 4. For question number 10, f of 2 plus h minus f of 2 divided by h can be written as 1 over h times 8 over 2 plus h minus 4. The slope of the tangent line is limit of the quotient difference as h approaches 0. We take the common denominator, 8 minus 4h. We reduce it by h, and when h approaches 0, the slope would be minus 4 divided by 2, which is negative 2. Thanks for watching.